Welcome, students. Today we're going to go in a little bit different direction and look at the difference between linear and nonlinear functions. So far, we've been dealing with all linear functions. Some words that you need to know in order to be able to identify linear and nonlinear functions are linear. Notice linear starts with the root word line. That is because a linear function is essentially just a line. So that is a function that has a constant rate of change also known as the slope. So if I were to draw a picture of what this would look like, it would be any of the linear lines that we've been doing so far. Notice that my slope is constant. Another word that you need to know is nonlinear. This is a non-line function. And this is a function that does not have a constant rate of change. Now there's many different pictures I could draw for this. All I have to do to make sure that it is nonlinear is that it is not a line. So something like this little squiggle would be a nonlinear function. Next, identifying from a graph is perhaps the easiest because a linear function will just look like a straight line. So if I look at my first function, if I trace over it, I see that that is not just a straight line, so that is nonlinear. If I look at my second one, that is just a totally straight flat line, has a constant slope, which is equal to 0, so that is a linear function. Then I can also identify from a table. Remember that we were able to use a table to find the slope of a graph, or slope of an equation, so I can do the same thing with a table. So what I need to do this is the rate of change, or slope, will be consistent. So you will need to find your change of your y and the change of your x and make sure that they stayed the same. Let's do an example. So as I look at my x's, 3 to 6 means I went up by 3. 6 to 9, I went up by 3, and 9 to 12, I went up by 3. If I go down to my y's, 40 to 32 means I went down by 8, 32 to 24 means down by 8, and 24 to 16 is also down by 8. Remember that my slope is equal to the change in y, so negative 8, over the change in x, which was positive 3. So for my first set, it's negative 8 over 3. I see that it's negative 8 over 3 for the middle and negative 8 over 3 for the back set. Since these are all equal, I know I have a linear function. Be careful and make sure that you've also simplified your slopes. If you haven't simplified your slopes, it's not going to come out equal, but they really truly will be. Next one. I want you to pause the video and then unpause when you're ready to check. Across the top, it was plus 2 the whole time. From 2 to 11, I went up by 9. From 11 to 33, I went up by 22. And from 33 to 88, I went up by 55. So looking at these slopes, it's not looking good, but we'll just double check and make sure they can simplify. So 9 over 2, 22 over 2, and 55 over 2. Notice that the only one that can simplify is the middle, but since none of these are going to turn out to be equal, this is a nonlinear function. The last place I can check is actually looking at the function itself, or the equation of the function. For a linear function, there are going to be 3 key rules. Number 1, x and y must have an exponent of 1. It doesn't always have to be written. Remember that x and y themselves have a power of 1 without actually writing it. So as long as you don't have any kind of an exponent showing, you're good. X and y can be added and subtracted to each other, so it's okay to add and it's okay to subtract them. And lastly, x and y can be in the numerators of a fraction but cannot be in the denominator. So it's okay for it to hang out on top in the numerator. For a nonlinear function, it will have a power other than 1. So notice this example has x squared. That can no longer be linear. X and y cannot be multiplied or divided if I want it to be linear, so a nonlinear function would show them multiplying together or dividing. And lastly, x and y are denominators, would be a nonlinear function. So notice x is on the bottom and y is on the bottom, so those are ruled out for the linear functions. Thanks for watching.